Hi there! Have you ever wondered how scientists make prosthetic and orthotic devices like these come alive? Well, they usually incorporate the principles of artificial intelligence to do this. So how exactly do scientists and biomedical engineers make prosthetics think like humans? Well, step one is to get the message. Think of it like a text. You can't do anything without data. So we measure this by taking electromyography sensors, or EMG, and measuring the signals that are in the electrical currents that are generated when your muscle groups contract. Okay, so we have this data and we just fed it to our very confused computer who doesn't know what to do with it. Now what? Well, that's where AI comes into play. And no, it's not sci-fi robots taking over the world, but it is still pretty cool, and it can help us understand this data through machine learning.
In machine learning, we can create computer algorithms that can study a training set of data, deduce patterns, and draw inferences. There are three main types. In supervised learning, you label and categorize your data. Part of this labeled data is used for training and creating the model, and the rest of the labeled data is used to test the validity of the model you created. After you've created an accurate model, you can use this to make predictions based on new data. In unsupervised learning, the data is not labeled ahead of time, and the computer simply has to identify the traits and categorize it on its own. Finally, in reinforcement learning, positive behavior is rewarded and negative is punished after every step, much like training a dog. This is used when prosthetics mimic a control limb to calibrate the movements between the two.
Scientists studied neurons from the brain to imagine a way for computers to think more like humans. What they learned was that neurons send and receive signals, and also that they can't work alone. They need to work together. They need a network to get anything done. And so, scientists created neural networks. Here's a look at your typical convolutional neural network. These are great because they can process image data using the red, blue, green color scale. On top of that, they're made up of densely interconnected, simple processing nodes, which include the input layer, the hidden layers, and the output layer, which are all used to process the data.
Possibly the most important thing to know about the neural networks is that it's made up of individual neurons of code. Each neuron adds up all its input values, gives them a weight that it multiplies the number by, and this weight is adjusted during the learning phase to identify the perfect relationship, and then it applies an activation function that will turn the total value into a number between 0 and 1. After that, it sends this number to other neurons and it passes it to the next column and the next one. In the end, the final values will help you categorize your desired output. However, your neural network can still be improved. After all, our baby neural network is not going to have the same problem-solving skills as a big, experienced one. That's why we have transfer learning. With this technique, we can reuse a pre-trained model on a new problem or network. That means we can feed all of our data to a super smart neural network in order to help categorize it easier. One example of this is VGG16. This is an expert convolutional neural network that studied 14 million labeled images 74 times, and because of this, it has gotten really good at categorizing data, so it's often used as a shortcut in these situations.